Welcome back to Math Defined with Mrs. C. This video is a mini course on adding and subtracting fractions and mixed numbers. We will look at several different types of fractions and mixed numbers, so feel free to skip around to find examples for what you need. I have time-stamped the different problems in the description below, but you won't want to miss out on the shortcut that I'm going to show you with borrowing and regrouping mixed numbers. So let's do this. Let's start with fractions and mixed numbers that have a common denominator. Looking at 3/8 and 7/8, we see that they both have a common denominator of 8. When fractions have the same denominators, we just add the numerators and keep the denominators the same. Adding 3 plus 7, we get 10 as the numerator, and we'll keep the denominator of 8. Now we have an improper fraction, which we do need to reduce or simplify. We'll divide 8 into 10 one time with 2 left over, and we'll have 1 and 2/8. But we can also simplify 2/8 by dividing both the numerator and the denominator by a shared factor of 2 to get the final answer of 1 and 1/4. Now let's add 3 and 4/7 to 2/7. We see that they share a common denominator of 7. So we can add the numerators, 4 plus 2 to get 6, and we'll keep the denominator of 7. But we also need to add the whole number of 3 here to our fraction of 6/7 to get a final answer of 3 and 6/7. We do not need to simplify the fraction 6/7 because 6 and 7 do not share any common factors. Next, we have two mixed numbers. The fractions have a common denominator of 11, so we can start by adding the numerators. 5 plus 8 is 13, and we'll keep the denominator of 11. Next, we need to add the whole numbers, 6 plus 2 to get 8. This time, we do need to reduce the fraction because 13/11 is improper. So 11 divides into 13 one time with 2 11s left over. And we can't forget to add this whole number of 1 to the whole number of 8 that we already have to get a final answer of 9 and 2/11. Now that we've covered addition, let's move on to subtraction. We'll again focus on fractions and mixed numbers that conveniently share a common denominator. The process is the same as with addition in that you subtract the numerators and keep the denominator the same. Let's look at 10/21 minus 7/21. The common denominator is 21, so we just subtract the numerators. 10 minus 7 is 3, and we keep the denominator of 21 to get 3/21. We need to simplify this fraction, though, because they share a common factor of 3. We will divide both the numerator and the denominator by 3, and we get the reduced fraction 1/7 as the final answer. Next, we have the mixed number 5 and 5/8 minus 3/8. Again, they both have a common denominator, so we start by subtracting the numerators and keeping the denominator, results in the fraction of 2/8. Then we bring down the whole number of 5 because in essence the fraction 3/8 has a whole number of 0 with it, and 5 minus 0 is 5. We also need to simplify 2/8 by dividing the numerator and the denominator by the shared factor of 2, resulting in the mixed number 5 and 1/4. In this next subtraction problem, there are two mixed numbers with a common denominator. So again, we will begin by subtracting the numerators. 9 minus 3 is 6, and we'll keep the denominator of 20. Then we subtract the whole numbers. 7 minus 4 is 3. And again, we need to simplify the fraction by dividing by the shared factor of 2, resulting in the final answer of 3 and 3/10. Now we are going to review how to borrow when you can't subtract the numerators. First, I'm going to show you the math in action, so to speak, and why it works. And then in the second problem, I will show you a shortcut that you can do once you understand why you can do it. Borrowing with mixed numbers can be very challenging because it is different than borrowing with whole number subtraction. You will notice that I wrote these two subtraction problems in a vertical format. I like this format because it gives me the space I need to solve them. Since the fractions have a common denominator, we start by subtracting the numerators. But we can't subtract 5 from 3. So we need to borrow from the whole number of 4. I need to borrow a 1, which will change the 4 to a 3. Now I need to write this 1 that I borrowed as a fraction with the common denominator of 11. And we know the fraction 11/11ths is equivalent to 1. I will add this 11/11ths to the 3/11ths to get 14/11ths. And I can't forget to bring over the 3. Then, to stay organized, I will bring over the 5/11ths as well. Now I can subtract the numerators. 14 minus 5 is 9, and we'll keep the denominator of 11. Moving on to the whole numbers, we have 3 minus 0, which is 3. Now let me show you the shortcut. These mixed numbers have a common denominator, and we can't subtract 4 from 2 in the numerators. So we need to borrow a 1 from the whole number of 10. Borrowing 1 from 10 will change it to a 9. Now for the shortcut. Instead of writing out the 1 we just borrowed as a fraction, we can accomplish the same thing by just adding the denominator to the numerator. 7 plus 2 is 9, so I can replace the 2 with the 9, keeping the denominator the same. Now we can subtract the numerators. 9 minus 4 is 5, and we keep the denominator of 7. Then we subtract the whole numbers, 9 minus 4, so 5 and 5/7 is the final answer. Next, we will look at adding fractions and mixed numbers with different denominators. It is not possible to add fractions with different denominators. So we need to find a common denominator for the pair of fractions and then write equivalent fractions using that common denominator. This first pair of fractions have denominators of 5 and 4. We need to find a common multiple or common denominator that they share. There are a few different methods to finding common denominators, but I'm assuming in this video that you already know how to do this, so I'm not going to spend a lot of time on this. I know that 5 and 4 share a common multiple of 20, so I will use 20 as the common denominator for this pair of fractions. To write the equivalent fractions, I'll start at the top, and 5 times 4 is 20, so I need to multiply 2 by 4 as well to get the equivalent fraction of 8/20. Looking at 3/4, 4 times 5 is 20, so I need to multiply 3 times 5 to get 15/20. Now I can add the numerators and keep the denominator. 8 plus 15 is 23, and we keep the denominator of 20. We're not quite finished yet because 23/20 is an improper fraction, so we'll need to simplify it using division. 20 divides into 23 one time with 3/20 left over. Next, we have a fraction and a mixed number with different denominators. I chose this problem to show you because the denominators 7 and 14 share a common multiple of 14. So we will not need to write equivalent fractions for both, only just for 6/7. Sometimes students think that you must rewrite both fractions with equivalent fractions, but we need to remember that the goal here is to have both fractions have the same denominator. We don't need to create more work than what we need. Looking again at the denominators of 7 and 14, we see that they share a common multiple of 14. So we'll just bring over the 3 and 3/14. And then we need to write an equivalent fraction for 6/7 using 14 as the common denominator. Since 7 times 2 is 14, we need to multiply 6 times 2 to get the equivalent fraction of 12/14. Adding the numerators, 12 plus 3 is 15/14, and then adding the whole numbers, 0 plus 3 is 3. Again, we are not quite finished because the fraction 15/14 is improper. 14 divides into 15 one time with 1/14 left over. Then we need to add the whole numbers 1 and 3 to get 4 and 1/14. This last pair has two mixed numbers with different denominators. I chose this problem because I want to talk a little bit about choosing common denominators. You probably noticed that in the first problem, the easiest way to find the common denominator was to just multiply 5 and 4 to get the common denominator of 20. We could do the same with 6 and 4 to get a common denominator of 24. And we could use this denominator for the equivalent fractions. But there is a smaller multiple that we could also use here. Do you see it? 6 and 4 share the multiple of 12. Now, it really doesn't matter which common multiple you use. It's just that I find it easier working with smaller numbers. So I'm going to choose 12 as the common denominator for the equivalent fractions. I'm going to bring over the whole numbers first. Then starting with the top fraction, 6 times 2 is 12, and 1 times 2 is 2. Moving on to the bottom fraction, 4 times 3 is 12, and 1 times 3 is 3. Now we add the numerators, and 2 plus 3 is 5/12. Then adding the whole numbers, 4 plus 2 is 6. We don't need to simplify the fraction because 5 and 12 do not share any common factors. I'm going to finish up with subtracting fractions and mixed numbers that have different denominators. Just like with addition, the fractions must have the same common denominators before we can subtract the numerators. Starting with 5/9 and 3/18, we can see that they share a common multiple of 18. So I'll bring over the 3/18 and I'll need to write an equivalent fraction for 5/9 with the common denominator of 18. 9 times 2 is 18, 5 times 2 is 10. Since our fractions now have a common denominator, we can subtract 10/18 minus 3/18 is 7/18. And 7/18 can't be reduced because its numerator and denominator do not share any common factors. Next, we have 6 and 1/4 minus 1/2. We can see that the denominators share a common multiple of 4. So I'll just bring over the 6 and 1/4. However, I need to write an equivalent fraction to 1/2 with a denominator of 4. Since 2 times 2 gives me that 4, I will need to multiply the 1 times 2 to get the equivalent fraction of 2/4. Now I need to subtract the numerators, but I can't subtract 1 minus 2. So I will need to borrow a 1 from the 6, changing it to a 5, and then I'll need to use that shortcut of adding the denominator to the numerator to get the equivalent fraction of 5/4. Now I can subtract 2/4 from 5/4 to get 3/4. And then subtracting the whole numbers, 5 minus 0 is 5. For this next pair of mixed numbers, we need to choose a common denominator that is different than either one has right now. Let's use the shared multiple of 15 for the common denominators. Starting with the fraction 2/5, 5 times 3 is 15, and 2 times 3 is 6. And we can't forget to bring over that whole number 3. Now let's write the equivalent fraction for 2/3. 3 times 5 is 15, and then 2 times 5 is 10. And we'll bring over that whole number of 1. Now we're ready to subtract the numerators, but here again, we cannot subtract 10 from 6. So we'll need to borrow a 1 from the 3, leaving a 2. Then using that shortcut again by adding the denominator to the numerator, and we'll get the equivalent fraction 21/15. Now we can subtract the numerators, and 21/15 minus 10/15 is 11/15. Subtracting the whole numbers, 2 minus 1 is 1. And the final answer is 1 and 11/15 because we can't simplify 11/15 any further. And that brings this mini course to its end. I hope you found it helpful, and until next time, keep math awesome.